All right, good afternoon, everyone. We are starting the meeting right about now, our CPDP lecture 2. Everybody, you're all welcome, warmly welcome to the NIALSC CPDP meeting today, this fine day, Wednesday, 19th of March, 2025. We would like to quickly start off with a brief remark, opening remark by the chair of the Lagos State chapter, following which we will quickly dive into our agenda for the day. Thank you very much. Please join me in welcoming the chair of the NIA Lagos State chapter, Architect Abiodun Fatui.
Thank you very much, Moniba. I would like to warmly welcome everyone of us that have taken time out to be part of this webinar. We stand at a critical juncture where our city, Lagos, is growing and technologies are evolving. Our understanding of our impact on this planet is deepening. Today, we'll dive into a topic that is both fundamentally urgent and relevant. Buildings are more than just structures. They are complex systems that interact dynamically with the environment. They consume a lot of energy, contributing sustainably to global carbon emissions. We must strive for a sustainable future. Therefore, this CPDP is supposed to help us to understand how to optimize energy performances of our building, which is very paramount. This is not just an academic exercise. It's a decision we will be taking about our building designs, materials, and operations of our building sequences, from the comfort and well-being of the inhabitants of our designs to the broader challenges of climate change, to the building environment response and climatic change. All this will be playing pivotal roles as we continue to design and create an environment that is good for the inhabitants of Lagos to habit. During this webinar, we'll be discussing the interplay between building designs and energy efficiency, which I'm sure Dr. Edward Oladibolu is going to show us, the relevance and the importance of this as architects in our design culture. The challenges before us is significant, but it's also an opportunity for us to stake our importance in the society. We can create buildings that are that are comfortable and functional, and most importantly, environmentally responsible. So I welcome you all. I thank you for attending this webinar, and I'm sure I look forward to an insightful and educative seminar by Architect Edward Oladibolu. And in closing for this speech, Architect Edward just got certified as his PhD. He's one of the new PhD additions to the chapter. We've decided to use these webinars to showcase the talent that the chapter has by bringing in as many as we can that have done their PhD. So he might be speaking a bit academically, but I'm sure that as architects, we can always manage to bring that academical discussion into the practice of architecture. So Architect Edward, you're welcome. Thank you for agreeing to be part of this. And I'm sure it will be a time well spent by all. As we go on,
thank you very much.
I might recognize some people, maybe after your presentation, just for us to keep the tradition, of showing respect to those few of us that we have to show respect to. I mean, this is not saying that everybody is not recognized, but I'm sure you all understand how the institute works. So you might need to pardon me for that later on. So Edward, over to you. Thank you.
Thank you very much, my chairman.
Before you carry on,
sorry,
sir,
Edward,
pardon me to properly introduce you.
Yes, thank you, Moniba, please.
All right. To get into this CPDP program we have for today and delve on the topic of, and dig deep on the topic of building characteristics and its impact on energy use, we will be receiving this from Dr. Architect Edward Adeshola Oladigbolu. He is an architect, construction manager, programmer, property developer, and researcher. He has built up a wealth of experience from working with top architectural firms since his school days at the University of Lagos, ranging from Craftmasters, Cityscape International, and Form Annex Associates, spanning a period of 20 years. He has won a couple of local architectural competitions while at Form Annex and shortlisted for a few foreign ones. He's a professional of the current trends in the School of Architecture revolution and being very versatile with the latest and best tools used in practice, which include and not limited to 3D Studio Max, Autodesk, and a host of others. Dr. Oladigbolu Edward is a born artist who later had his formal art training at Lukman College of Art, Ibadan, where he learned the art of oil canvas, acrylic, watercolors, pastels, and others, and later proceeded to get its certificate in desktop publishing, where he learned advanced computer graphics, simulations, and animations. He went ahead to acquire his BSc in architecture from the University of Lagos and MED also from the University of Lagos, with a master's degree in construction management from the University of Lagos with focus on facility management, contract practices, and construction project management. He's a fully registered member of the NIA, the ARCON, and Association of Architectural Educators. He has also gotten a couple of other international certifications, which include Building Performance Analysis by Autodesk, Chaos Group for 3DS, amongst others in view. Dr. Oladigbolu Edward got his PhD at the University of Lagos with the focus on the building envelope and its relative performance to energy efficiency and thermal comfort at the Department of Architecture in 2024. He has more than 20 papers published in high reputable journals, locally and internationally. Dr. E.A. Oladigbolu has been a lecturer at the Bells University of Technology for more than a decade, where he has held several notable positions, first as a course advisor to undergraduate students, studio coordinator and examiner to undergraduate and postgraduate students, program coordinators, and a host of other things. And he's also now a member of the postgraduate board at the Department of Architecture, Bells University. Dr. E.A. Oladigbolu is fully registered and practicing with several notable projects in Lagos State and the environs. One of his very notable projects is the STNL Towers at Alausa, which he did under the guidance of architect Charles Ebudom of Formanex Consulting. He is the principal partner of Lages and Associate Consultancy Services and Land Academy, a full consultancy firm and an organization that trains architects in the use of modern architectural, engineering softwares, and other programming languages. Please join us in welcoming Arch Dr. Edward Oladigbolu. You're
Thank you,
welcome, sir.
thank you, thank you. Thank you very much, Architect Muniba. Thank you very much, Chairman, Lagos State Chapter, Architect Abiodun Fatuyi. Thank you very much, everyone, and all the executives. Let me start by greeting the president of NIA, which is Architect Mubalaji Adeniyi. Good afternoon, Chairman, Lagos State Chapter, Architect Abiodun Fatuyi. Good afternoon, every member of the Education Committee and the Executive of Lagos State Chapter. And good day to every one of us, colleagues, and everyone all over the world watching us today. My name is Architect Dr. Edward Adeshola Oladigbolu, and I will be presenting my topic today on the CPD Lagos State Chapter Program for Architects. And let me share my slides now. All right, so my topic today will be on building envelope and energy efficiency of high-rise buildings in Lagos metropolis. Majorly is basically on any kind of building, but energy efficiency and energy usage is more examined in high-rise mega structures. All right. Building sector is the highest consumer of energy worldwide. Globally, building sector consumes more energy than any other sector, from construction to usage to any sort of activities. Building envelope is a primary determinant of building energy performance. The envelope of the building is a major determinant of the energy used in that building. And the architects, we were responsible for that. The increasing energy efficiency is essential in the topics. We know the heat that is very conversant with the environment, the atmosphere, and all that we need to cool the building in order to achieve thermal comfort in each of our buildings. The sustainable development goals are a priority for the government and around the world. It's very important for us to meet up the sustainable development goal. And building accounts for more than 40% of energy consumption. All the energy consumed all over the world, building accounts for 40% of them. And within this 40%, urban center consume 80% of that energy, because most of the development are within this urban center. And in Lagos, we can see, which is far really urbanized, most of the mega structures are located in Lagos. Energy efficient building is important to achieve SDG 11 and SDG 13. And we know what they say, climate resilience as SDG goals. Then we can look at buildings, majorly the high-rise buildings, from the 5 different generations. The first generation of high-rise, which is more particular about the stability. The second generation, we looked at when building were developing materials. The third generation was when glass became fundamental property of the building. And fourth generation was when issues started arising due to energy consumption. And the fifth generation, which is now the present generation, is looking at how to optimize this energy that is being consumed by buildings. Now, building performance robustness. This is very important. We start looking at buildings, analyzing the performance robustness in each of the building envelope. But why do we study this? To quantify the impact of the uncertainty to make informed design decisions, to reduce the gap between predicted performance and operational performance, to ensure desired performance over building lifespan. But what are we actually studying? To identify uncertain and influential parameters that impact the building performance, to identify the most influential uncertainty sources, to identify appropriate methods that quantify the impact of uncertainties through scenarios analysis. Then we look at how to quantify robustness using different methods through the use of scenario analysis, which we'll be looking at in the course of this discussion, to facilitate design decisions, considering multiple performance indicators and corresponding robustness for different stakeholders. This is being shown in comparative study and demonstration using scenario analysis by Rajesh Korede. Now we look at the building envelope itself. The building envelope includes facades, which interact with the outside world as a social modifier for the microclimate. It isolates spaces from environmental temperature and humidity fluctuation. So investing in building form and enclosure is a key approach to achieving NZ. NZ, which is net zero energy building. These forms of building evolve over generation, and since the requirements were relatively simple and change was usually very slow, the design, the building materials, and the construction techniques evolved at a pace dictated by matching needs and available resources. Now, let's look at these 5 generations and how they have their relevance has moved from the first generation to the 5th generation. Now, from the first generation, which is the first batch of tall buildings, globally, we're looking at it globally now, and we see that the first tall building was in 1885, and what were the objectives? Majorly, they're just compact shape, large volume, high levels, thermal mass facade. You can see typical energy performance characteristics are low percentage and facade transparency, heating, elevators, main consumer of energy. Then we look at the second generation from 1916, which is more particular about zoning laws. That was what they were particular about in the high-rise buildings they were doing. So the third generation were the invention of glazed building from 1973. Then we looked at the fourth generation was in 1973 to present day, and that was when most of the high-rise buildings in Nigeria were developed. They fall within the fourth generation, which has to do with compact shape. That was when the energy crisis started, and they were looking at how to mitigate the reduced energy from 1973 up to date. Then fifth generation has to do with the rise of environmental consciousness. So that was from 1997. And environmental consciousness has to do with how to harness, the building performer, how to use the sustainable means, to utilize environmental factors in order to reduce or mitigate increasing energy demand in buildings. And you can see the typical office lighting levels for each of those generations and the energy U value, ventilation strategies that were used, air condition, mechanical, all these results to high usage of energy, mixed mode, exploited double skin facades, all sorts of conditions. Now look at high-rise buildings in Nigeria. You can see there are so many high-rise buildings in Nigeria and in Lagos State in particular, but these are the highlighted ones. Because the Great Nigerian Building, it was built in 1979, which falls into that fourth generation, where energy demand became very critical and buildings are harnessing, are trying to reduce energy consumption in buildings. And you can see Stalin Tower. This was then the tallest building in Nigeria. That's Necom House, 1979 as well. Eco Hotel and Towers, Eco PL with 2016, Heritage Building, and so on and so forth. We have, I think from listed number, we have more than 200 high-rise tall buildings in Nigeria, and they consume a lot of energy. But how are architects designing? How have they been able to harness the building envelope to curb or mitigate the energy demanded by these buildings? So we need to look at the energy flow path in buildings. Before you can be able to harness the energy, you need to understand how energy flows from building and around that building. So, and this, as a source from Clark, 2001, look at infiltration through natural ventilation, adjacent zone radiation. You can see convection, metal conduction, air point node. So this construction node and all that, it shows that energy and heat can pass through the walls through either convection or conduction. How do you mitigate this? Through composite walls, and all sorts of the solar heat gain coefficient and all those ways that heat can transfer from outside into these buildings. Now, afterwards, we look at energy optimization. What are the factors that really affect building services, building energy optimization? And this is being grouped into the table, the set as shown above. We show the key factors influencing energy consumption in buildings. To the building services, the fuel, type of system, plant efficiency, operational regime. Then the building envelope itself, which look at the size, the building form, the shape, the materials, the ventilation, location, the orientation. Then human factors, which is the comfort requirement, the occupancy regimes, management and maintenance, activity, access to controls. Then we have the external factors, which is the climate. So we can see how these connect. The building services connect to the building envelope through automatic controls. The human factors connect to the building services through user controls. The building envelope connects to the human factors through window controls. So with this, all connect together as a set will optimize the energy usage in any building. Now, Matilde examined the key indicators for energy to understand energy, the key variables, which include the system variables, which are on the requirement, which are the lighting, the services, and the internal loads. Then you have the internal load schedules, internal loads, the electrical usage, whatever internally you are using in your building, your system schedules. You have the building geometry, then your real-time weather data, the weather of that environment, thermal characteristics of the building envelope. That's the characteristics of the elements, the building form, the building materials. What are the thermal characteristics of those materials that you could use to mitigate energy consumption in each of the building? Then the unbound environmental influence. Then we looked at that as being grouped, which has shown the same way. So these factors can be used for what we call the shoebox model, that's the building energy modeling, because that is the best way you can identify which of these variables is actually influencing the energy consumption of the building the most. So we look at all the variable system, internal load schedule, environmental influence, and so on and so forth. So there's a framework that frameworks arising for mitigating energy usage, but in the conceptual framework shown above, we show relationship between the physical domain and the virtual domain. In this way, we can mitigate energy consumption of any kind of building even before it is being built. We can identify building envelope energy usage, energy use intensity before it is being built. But using all the variables, using all the characters, all the indicators that is being calculated into the building usage. So this arises to simulation. There are several simulation softwares used to measure the energy consumption of any building. And some of them are listed above, which is Energy Plus, Energy Habitats, Edge, Green Building Studios, Revit Insight 360, Passive House, DaySim, Design Builder, Simulation CFD, etc. So this measures the passive and active usage of the energy in each of these buildings. And you can measuring energy efficiency of buildings, global practices. So many researches are being done over the world, and you can see researches from Harvard, from KMOL, which indicated the importance of the building envelope to the environment and to the energy consumption. And you can see some of this. You can see the factors that are being analyzed and the energy usage in each of them. The mechanical cooling takes precedence, but the building envelope and the environmental factors, the building elements are very important to mitigate the energy consumption of those of that particular building. You can see that using it to measure different conditions, and you can use that to calculate the energy consumption, even identify the bill you are meant to pay for the building. And these practices are noted all over. In Holland, they use passive house to measure, so whatever bill they are bringing must be in conformation to what you're actually using in the building. You see this for measuring daylight. You have the Ecotech. You can see this Berkeley comfort model simulation. It shows the daylight factor and daylight autonomy through the spaces of several buildings. You know, this shoebox model method, which shows the energy consumption of each of your spaces per month over the period of 1 year, where the illumination is bright, where we have raining, where you have daylight. How much energy will you use over the period of that time? So you can see more. This is to show the massing, to show the lighting performance along each of the spaces. And you can see this is simulation CFD showing the airflow within each of those spaces. Now, we have samples here in Nigeria where we calculated the energy consumption in one of the major high-rise buildings in Nigeria. Example here is the Heritage Building. It's a LEED certified building. And we calculated the energy usage to see if it meets up the benchmark that has been stipulated for the 2030 benchmark to meet up the SDG goal, Sustainable Development Goal. And this is it simulated through Revit 360. And the same, we did that for Nestor Building, a LEED certified building as well, Heritage Building, King's Tower, and the Churchgate Building. Now, these are the energy gotten from each of that. As much as they were being recognized for LEED certification, they still have some adjustments to meet up the benchmark. You can see the Architecture 2030 benchmark there. The energy consumed after analysis through simulation is 208 kilowatt hour per meter square per year. The energy usage needs to be reduced to 110 kilowatt hour per meter square per year in order to meet up the benchmark stipulated from Architecture 2030. And to meet up ASHRAE 90.1, it must be 171 kilowatts per meter square per year. And it cut across. It's the Nest Oil Building meets up the ASHRAE 9020, Churchgate Building, same. But the simulation approach will allow us to identify which of the factor, which of this element around is influencing the energy usage. Because if you look through the typical methods of approval, of checking sustainability, is just to see the number of windows. But what is the lighting level? What is daylight factor? What is daylight autonomy? These are the things that we are more concerned about in order to achieve adequate lighting in the space, in order to reduce energy consumption. So with this simulation, you'll be able to identify each of the factors from building orientation. You can see building orientation, as indicated here, has no much effect because most of these are open offices with open glazed windows. There's adequate daylight autonomy through each of the spaces. But the HVAC system, the infiltration, you can see the infiltration through the different materials is important. The materials used based on the convective properties and the conductive properties affect the heat exchange from outside space to internal space. You can see the lighting efficiency. Lighting efficiency is based on the usability, the time, the schedules, then the operational system as well. And we look at the roof orientation, roof construction. Then we looked at the relationship between the building envelope and the energy efficiency as well, which looked at each of the facade elements. How does this affect the energy consumption? Each of them are being indicated as shown above. Now, this process shows how you can go through the simulation process to achieve your energy efficient building. Firstly is by measuring the building, if it has been constructed already, measuring it, plotting it, use through GPS mapping to know the latitude and longitude along and allocating it to a weather station. Then you develop the building information model. The building information shows all the details plotted accordingly. There are so many building information model softwares, which are, we have Revit, you have Vectorworks, SketchUp, ArchiCAD, and so on and so forth. So from there, you take into a building performance analysis, the BPA, which you have to do the energy mass model, the shoebox modeling. You have the energy assessment through Insight. There are others. We have the Green Building Studio. We have the Edge. You have Passive House and Habitat, Energy Plus, and so on and so forth. So from this, you can use that to identify the energy consumption at the end of the day for each of the building and identify which of these elements is affecting the energy consumption of that building. So you wouldn't randomly suggest by just looking at it and say, there'll be adequate ventilation. There will be, we have adequate lighting. We don't need VRF AC. The envelope affects the usage of energy, and it is necessary you identify the elements that will influence more energy consumption before you go into the mechanical aspect of that building. Well, in conclusion, energy benchmark is pivotal to achieving sustainable development. Lagos as a metropolis has more concentration of high-rise buildings, energy use intensity to be minimized in order to contain global warming, urban heat island. Simulation serves as a pivotal method for assessing energy use of large buildings. Building envelope is very imperative in reducing energy use intensity of high-rise buildings or any building in particular. So recommendation, we expect development of energy use intensity per unit area for all buildings in different localities. Yes, globally now, buildings now have a statutory energy use intensity benchmark per units per area.
Perfect.
We need to develop energy use intensity per unit of each building, depending on the volume, depending on the location. Energy use intensity benchmark needs to be developed. Government intervention in staff training and to curb and determine the energy usage of each building. Government to initiate building energy consultant to mitigate excess energy usage. Simulation specialists should be involved in building process and in approval process as well. References as indicated there. Thank you.
Thank you very much, sir.
Yes, thank you
that
very
was
much.
a very
Yes.
enlightening presentation.
Yes.
We absolutely enjoyed looking at all of the different aspects of this. I will, if there are questions, please can everyone just type in the questions either on the group chats, and we will temporarily hand over to the chair of the practice committee, Architect Dafe. We will to give us any comments, feedback, or questions.
Thank you.
Okay, yeah, thank you very much, Muniba. Thank you very much, Architect Edward, for the beautiful presentation.
Thank you. Thank you very much.
Indeed, the knowledge shared is going to be very useful now and in the future. So we are looking at questions. If you have any question, or you want to type it on the chat, you want to discuss it here, you can unmute yourself and just briefly share your questions or comments. If you have insights as well, you can share. Okay, so there's a question, please. Sorry, please. There's a question here. That's from Taiwo. He said, kindly explain how one can carry out energy modeling for our local softwares, e.g. SketchUp. Dr. Edward, did you get that question?
Yes, I'm with you. I'm with you.
Okay, so can you kindly explain?
All right. If you are using SketchUp, the most important thing is this modeling is being divided into phases. There's the BIM and there's the BPA. The BIM. Are you listening?
Yeah, please, can everyone mute their mics, please? Please.
Okay.
Carry on, sir.
You have to unmute yourself, sir.
Okay, I see. Sorry, I didn't know I've been muted. So can you hear me now? All right. So you were asking, how can you do a shoebox model for SketchUp? Like I was saying, there are several BIM softwares and there are BPA softwares. SketchUp falls under BIM softwares. BIM, which is building information modeling, where all the characteristics of the building, the materials, the properties, the location can be done with SketchUp. The properties is in the setting. We can run. One of the most recognized one actually is Revit. It's easier to do, but in SketchUp, you can set up all that too, as well as ArchiCAD. But you have to convert your model into, I think it's XLM model package. So that if you convert to that particular package, I'll get the name of that package. You can transfer to any BPA software. The BPA software are Green Building Studio, Edge, Insight 360, DaySim, and Habitat. So that particular application can accept, it can accept SketchUp directly. But when it's converted to that particular model, it can be simulated in any of the package. So we will run training for that as time goes on, but I don't think there's enough time to be showing you that here. Any other question, please? Hello?
Edward.
Oh, my chairman.
Thank you. Thank you very much. I'm particularly excited about your presentation, and I would like to appreciate how short and punchy, you know, your presentation was. The truth is, we need to start considering energy usage in our designs.
Yes.
Even if you look at the cost of powering your house, a house where you live in, I'm sure it should spark the thought of us now beginning to consider how, you know, to make our buildings more energy efficient.
Yes.
Which is one thing that the chapter is trying to achieve. You know, at our last meeting, we brought in somebody from Edge certification, and she was telling us.
Okay, I think we temporarily lost the chairman, but would definitely, he'll probably join us in a few more seconds. But yes, sir, we absolutely enjoyed the lecture, and I'm sure we're all excited and looking forward to how this can impact with our designs as chapter members, and for us to probably go back and do some deep dive as well into research for our designs, even as we do more contemporary designs as we work. So would like to very briefly thank you so much, sir, for your time. We totally appreciate you taking time out of your busy schedule. We know that it's not easy to, you know, exclude yourself perhaps from all the work you have to do. I mean, and I always say to everybody, time is money. So you've spent money for us today. So thank you very much, sir.
Thank you very much.
We totally appreciate you.
Yes.
Pending when the chairman comes back online, I would like to recognize Architect Adebayo Odusoyan, FNIA, Architect Specs. Thank you for joining us today. I'd like to recognize just going through everybody who is in on the Zoom call. Architect Femi Adewahab, we see you. Branch Chair, Ikeja Branch. Thank you very much, sir, for your time. Running through. Thank you, everyone. You are all very special. Just because we didn't mention your name specially, but we greet you specially. We appreciate you taking time out of your busy schedules to join us on the CPDP for today. So let's all know that after this time, the presentation will be available on the website for download and access. And the recording is also on our YouTube page. The link will also be posted on the platforms. So you can, if you missed it or you know someone who's like, oh, I missed it, please, the recording is available on YouTube for your review. And I will just hold on for a few more seconds for the chairman to give us the closing remarks. And then I'm sure we all have very busy schedules to get back to. Mr. Chair, are you still available? Okay, all right. So, yes, but thank you, everyone. Everything will be available, both the YouTube videos and the presentation will be available on our website. We'll push that out as quickly as possible. Thank you, everyone, for your time. The chairman sends his apologies because his network seems to be giving him a bit of a challenge. We appreciate everyone. We'll see you very soon. Don't forget, we have the next chapter meeting at the end of the month. Information on the dates would be provided. However, it will be next week, Thursday. Oh, I'm so sorry. Hold on. It will be Thursday, yes, the 27th of March. Yes, please. That will be the next chapter meeting, but information will be put on our platforms. Thank you, everyone, for your time. Thank you, especially Architect Dr. Oladigolu.
Thank you for having me. Thank you very much for having me.
And congratulations once again on your PhD. We
Thank
see
you very
you.
much.
We appreciate you. Thank you. And thank you, everyone. Have a good day. Bye.
Yes. Bye.